Hello there. Right, this is Danny at Ryan Robots, and I've got a rather nice new toy. This is an Elecfreaks Microbit Smart CuteBot Pro. And this was sent to me by Elecfreaks. Inspire your creativity and explore the marvellous world of robotics with CuteBot Pro. So I have actually been told this is a pretty cool starter kit for someone beginning. What have we got? There's going to be an ultrasonic sensor, the robot. Come on, let's get it open. Right, so first thing we've got is a user guide. We'll take a look at that later. We have a line following track, which I can add to my collection of line following tracks. What I understand is this is sensor packed. Now, I had a Microbit V1, but not a V2, so Elecfreaks have sent me a V2. Some manuals. So there's the V2. The first thing I noticed really is looking at the back of it. It's got this nice clear antenna, but we've still got, there's a built-in speaker. Okay, cool, so we don't need to put an external speaker. You got your processor, accelerometer, compass, which we already had, pins down here, something to stick a battery, so a 3-volt battery, maybe a standard LiPo or button cell if you wanted that, a USB reset button. We've also got an ultrasonic sensor, echo, trig, voltage, ground. It's going to work the same as an HCSRI 4. And the robot. Right, first thing is it's got a nice slot for the sonar to go in. And it gives itself a nice little face. So it's got a single wheel up front, which is like a skid, 2 wheels at the back, 6 wires. That means each of these motors, which I think are N20s, have built-in encoders, so you can write code that can tell how far it's driven. Servo motor and 3-volt sensor pins here. Ground, 3 volts, 19 and 20, so maybe some pins for expansion. Maybe you could put an I2C thing here. We've got a slot for a single 18650 rechargeable battery. There's an on-off switch, always handy. We have some RGB LEDs here, and I think these 2 front ones are RGB as well. 1, 2, 3, 4 line sensors here, so you can use that for line following. And there's a training button. Don't know what we're going to do with that yet. There's also these expansion ports here to bolt things in with. And that looks like that's how the wheelbase has been bolted on, these expansion ports. And these are nicely, look at these, nicely reinforced eyes. So whatever you put in there, it's not coming off easily. I need to go and find an 18650 and maybe get some code and try it out. Right, the Microbit clearly pops into this edge connector. I am assuming, and maybe I should check the manual, that the Microbit's LEDs face forward. Let's just take a quick, yeah, there we go. Okay, we have an Ultrafire brand 18650 here, and this is where you want to be very careful that you align the positive and negative. Oh, well. Oh, hello. Don't know if that's a standard Microbit thing or part of this. Hello. I think this is a standard Microbit thing. Apparently it says it's easy, affordable and life-changing. Well, I guess for someone who's never done any programming, it could be life-changing in that this might be their first encounter with programming. And it's quite exciting, really. As a first starting point to play, I think a robot, I mean, I might be biased, would be quite exciting because you've got nearly all the sensors you want here. Enough sensors with the encoders and the distance sensor to make some quite interesting robot behaviour. Place the 4-way probes directly in front of the map background area. Okay. I don't think so, because I suspect we have to put something code on the Microbit, but we'll see. Maybe it's going to pre-program it for us. Well, let's try it. So put the probes in front of the 4-way, directly in front of the map background area. Oh, it's showing it just the background, and then press the learn button, which is this one here. It's got to be this train button. Okay, 1, 2, 3, 4. It's learned something, and they're flashing rapidly, like it said, with added sound effects. Yeah. It says when learning fails, we get a red light, but we're not getting a green light or a red light. Oh, wait. At this stage, and I'm going to turn it off, I'm not supposed to have plugged in the Microbit. Okay, let's take the Microbit out then. And that'll also stop the noise. Okay, let's try this again. Here we are. 4-way, front of the map background, press the learn button. Okay, and now it's going. Okay, so there's obviously an onboard controller to which the microbit is additional. Okay, now it's flashing. Now we can try, oh, well, it went green already, but okay. All right. And, oh. So these LEDs here are showing the status of the line probes. Sunlight bias. If I put my hand here to cast a shadow, it turns off. It turns off. Because I'm doing this in sunlight, so I'm not using my studio lights, and sunlight appears to have kind of biased it. So what it could do with would be a little bit of shielding around there, just so the ambient light isn't messing with it so much. Right, well, apparently the next step is to go and code. Like their book suggested, here I am on Make Code. Now, they don't suggest it here, but if you're going to go and build stuff, I would suggest you sign in so you can save your projects for yourself. Let's go do that. So I've now got myself signed in with my little badge here. New project. Now we can give it any name we like. I mean, they're saying CuteBot Pro. I'll say CuteBot Pro #1. Welcome, tour of the editor. If you've never used this, I recommend it. If you have, then you know what, you can skip it. And if you're used to Scratch and other block languages, this is very similar. It also allows this transition straight to JavaScript. Ooh, what's this drop down? Haha, or to Python. I tend to like Python. That means you get this off-ramp between block languages and text languages, which works for me. Okay, but we've got to add an extension. Let's search, because there are plenty of extensions here. CuteBot Pro. So notice there's some different models here. What we're working with is the CuteBot Pro. It's added an extension which gives us a whole bunch of additional blocks we can work with. Their first idea is to do a police patrol at a fixed distance. Okay, headlights, rainbow LEDs, alternate between red and blue, like a police car. And when you press the button A, it goes forward 100 centimeters. So what's interesting here is they're showing set strip as red. What they've not said is that this comes from the NeoPixels box. So would have been nice if in their manual they had suggested that's where it comes from. Let's grab that and we'll put that in. Pin 15, okay. Question is, have they printed anywhere on the bot itself that these things come from pin 15? So a close-up of the robot here reveals that there's a P15 0 and 1 on the NeoPixels on the back, which has actually only got 2 LEDs. Okay, and so what this is actually doing, the reason this is red is it's a variable. So it's creating a variable called strip with these bits in it. So strip is an object, I suppose, containing a bunch of NeoPixels. Input, and on button A pressed, go forward 100. So CuteBot has got go forward, go left. Here, cm. It can do centimeters. The reason it can do centimeters is, you know, I mentioned about those 6 wires on the motors with the encoders. That means it can detect how far motors are going. So when you say 100 centimeters, it's going to be pretty close to 100 centimeters. And in their forever loop, set LED headlights, which is in this one. Set LED headlights. Okay, so they set left and right. So set the left one to red, which actually they didn't do all. They're going to do the strip as well to show the same colour. Under NeoPixels, right? And is that going to be the same? Oh no, okay, so we're going to make the strip blue when the headlights are red. I see. And then we do a bit of time. So where's time then? Is it in basic? Pause, yep. So 500 milliseconds, which is, it's going to drop down. I was going to type it, there we go. And we should be able to duplicate some of these blocks, save us some time. There would be 2 blues. Now, awkward thing here, there's a definition of red and blue, which is not necessarily the same as this definition of red and blue. Interesting. Maybe this would be easier to reconcile in the Python version. And that'll be red. And we want to do this, so we've got a delay. Okay, cool. Right, so I guess it's time to plug it in. it is just USB micro, so like any other USB micro into the computer, it'll go the same way. So I plugged in the micro bit, which has still got the demo program, so it makes a load of noise when programming it in, or plugging it in, and just know about that one. Oh, and no, notice it's also shown a kind of a demo panel. So let's see what happens if we hit the download button. I'll connect to the computer. Yeah, there we go. Paired it with my browser. Oh, okay, let's try this. And the noise is starting again. Okay, download to stop the terrible noise. Right, that's downloaded. So let's see if I turn it on. We have ourselves the flashing lights. There we go. We got the lights corresponding to the line sensors, which are enabled all the time. But it is doing pretty much what it said. Okay. And then when button A is pressed, was it? Or oh, there we go. I might need a bigger space to test that. So switching for 30 is going to be as easy as 30. Download button on my desk. That's pretty good. And that's what you get when you use encoders. That's why I think most robots should come with them, because you can measure 30 centimeters. Did we see any veer there? See, if I align that, yeah, we're seeing veer. So they're not yet doing straight line correction with those sensors, which is something we can perhaps program. Okay, so this is already a pretty cool experience out of the box, that we've been able to kind of get some code running, get some lights flashing, which is always going to be fun and exciting for first experience. We've got it driving a certain element, so we are already using some of the sensors. And look, when you've now got distance sensors, you could look at how you can make specific turns. You could possibly even start collecting data and doing, well, I don't know if you've got the memory to do something like Monte Carlo. Might be a bit complex with only one distance sensor too. But also, this Python bit, this is fantastic. This is part of MakeCode. Input on button pressed, A. On button pressed, A, okay. So, oh, I see. So we're connecting this function here to this on button press with button A. So we're creating a function we use as a callback to handle an input. Again, it's sort of a shame that here we're doing RGBA colors and there's just NeoPixel colors blue. And it doesn't really tell me what that might be. So, but can I say show color RGB? You know what? Something we can do in the Python that we can't do necessarily everywhere is we could say blue equals, instead of getting, well, actually, look, why don't we use this same color instead of defining our own? Oh, wait, no, blue is here. And we can do the same here, because look, that's actually fetching an RGB color from an existing list. Let's try that. So here's the fun, right? Once you get started, you're trying stuff out, and I'm probably going to spend the rest of the day trying this stuff out, because that's a load of fun. Yep, that works on both LEDs, and I'm now using the same color for both. There we go. Can I go back to blocks? Well, yes, it's saying red and blue, but it's probably a little bit confused about what red and blue here were, because it didn't show those in the list. So, interesting. One more thing. I've worked out you can use this Python editor, and you can use this built-in help. So if I drag that as if it was a block, I get code. Oh, because I've played with it before, I get this. So, okay, digital pin, P15, I guess. 2 pins, RGB. Very cool. And I can say strip dot show color blue. Okay, some nice auto completion there. It's really helped me. How can we do some display stuff? show icon. Show icon. Let's see. Heart, which I guess is a basic one. So you can code directly in Python with the help of what was in the blocks too. This is a pretty cool coding environment. I'm impressed. Oh, one thing I've also observed, by the way, there are 4 LEDs here which show the battery level. So 2 out of 4. So let's go put this on here. We have line following. Just when I thought I'd figured it all out, turns out this has also got, from the microbit, of course, it's got all the microbit sensors, which means it has light level sensing through the LED grid, which is what this particular example uses. But it's also got that accelerometer and gyroscope that are built into the microbit. So actually building it around the microbit gives it a bunch more sensors. Apparently there's also infrared for IR control. I didn't spot where that sensor is, but that's cool. But I guess you could also pair this microbit with another microbit and then use another one to drive it and control it using their radios. Pairing a microbit with a robot, that's pretty cool because you get a bunch of sensors built in. Awesome. This plug here charges the 18650 and the charge indicator there works. So one important part of a product like this is the documentation, and as well as the booklet, and this is their wiki. We've got some instructions, we've got some product features, so we can see all of the features on there, what it says, encoder motors. So there's a little bit of not quite ready yet. I suppose it's early days, they'll probably fill this out. These case libraries are different from the ones in the manual. So if you've exhausted what's in the manual, have a look at these. There is some overlap, but there's also things that we don't have. So for example, voice control. Wow. Okay. On start, on lap. So this is more clap control than voice control, but yeah, okay. So we've got examples here that you do not have in the manual. So it is worth following the online cases as well. Well, for extra enjoyment and exploration. Teaching objectives, what you might need to prepare, that's pretty cool. Some exploration, which is really nice. So some extension tasks to maybe help learners get more from this. Now, one thing I have noticed is there's a lot of code for the blocks, but if you're trying to do stuff with Python, it's not as well documented. And one of the areas where this has shown up is playing with a line sensor. So they've got a line following example, and over here, if I set these, I can set these to the right values based upon these lights, and they have an instruction showing what each of these light values should be. However, when you translate it over to the Python method, you just have tracking state 0 to 12 presumably, or 0 to 16. Those do not map to the binary version of that line. They do not map to anything. I can't tell what that enum is supposed to mean in terms of the tracking state. I was hoping it would be a binary representation, but 12 for those 3 being off, don't think that makes sense. Does it make sense the other way? No, it doesn't. So there's no state of 3 ones and a 0 or 3 zeros and a 1 that corresponds to 12. And I was hoping that in this I would have maybe some kind of thing that tells me what the Python methods might be. Sadly, I do not see this particular instruction here, so that's a bit of a shame. And to be fair to them, they are talking about this as being kind of a life-changing first experience with STEM and building, where actually blocks code makes sense. And the other part about this make code actually is there is a JavaScript tool, but I think JavaScript looks quite similar to the Python. You know, you've got different syntax, whether you've got, you know, colons or braces. It's the same functions and it's the same issue. But again, I may not be really coming at it fairly because the target market here are going to be working in blocks. I'm going to have lots of fun with this. If you, as the viewer, would like to have fun with this, I have a code for this that will be in the video description that you'll be able to use to get a small discount on buying these if you buy them directly from Elecfreaks. So please do look in the video description. I hope this has been interesting. I think it will be. I think I'm going to have a load of fun with this. I'm going to try it out with some of my kids. I'm going to try it out with some of the people who I mentor. Let them play, let them write code. It's more robot programming than robot building. There's very little building involved. But in terms of getting someone a platform that they can just start playing with, yeah, this is good fun. Go make stuff and be awesome. Bye.